Cowabunga! What's up, dude and dudettes? It's Mr. Cockbrunner. Hopefully you're catching that gnarly wave or at least put on some sunscreen today. But what we are going to be doing today is solving quadratic functions, factoring, and graphing. I'm assuming you're going to like graphing a whole lot more because you know what we're going to be using for graphing. However, factoring is what we did at topic 5. So we're going to look at all that stuff. So hopefully you remember and can recall what we've done. Let's get at it. Again, the objective, solve quadratics by factoring. Perfect. All right. If a quadratic equation is written in standard form, that means ax squared plus bx plus c equals 0. We're going to be using the zero product property. Before, we used to call this what? If you look down here, we said y equals ax squared plus bx plus c. Now what are we doing? Very simple. We're taking y and we're going to set it equal to 0 because that's where we're looking for, is that x-intercept. And where do we have our x-intercepts? Are on the x-axis where y is 0. So anything that you see as a y, we're going to put as 0, and that's how we're going to solve these, all right? So let's just get our brains working. Remember, this is that binomial, the factored form that we talked about. We're setting them equal to 0. So if this factor is 0, and it doesn't matter what we get for this answer, it's going to still equal 0. That's what this whole zero product property really means, all right? Taking one of those factors and getting a product of 0. So a factor times a factor getting you an answer. We're going to get 0, and it's real simple. All we are going to do is take these sets of parentheses, drop them, and set it equal to 0. What number minus 1 gets you 0? If you don't want to solve the riddle, just do the algebra. You get x equals 1, because what's 1 minus 1? 0, of course. So here's one of our answers. And then the other answer is, again, just drop your parentheses when it's in that binomial form or factored down form and just solve the riddle. What number minus 5 gets you 0? If you don't know it, again, whatever you do to one side, you do the other. So I'm going to add 5, solve with algebra, and I'm going to get x equals 5. All right, here they factor out a GCF, and all that's going to be is x equals 0. So there's one of my zeros. And now let's just drop parentheses for this one. X plus 4 equals 0. Again, we're just going to do the inverse operation, and we are going to get our two solutions as 0 and -4. So again, remember, any quadratic, they could have one solution, two solutions, or no solutions, all right? Excuse me, I had to take a quick sip of water. So here's what we're going to be doing. When we get to factored form, all right, or standard form, we're going to make it say a squared plus b squared equals c squared. And then we're going to swap out the y for 0, all right, because we're going to do that zero product property. If we can GCF it. We're going to do the x method. Or if it's a special case, we might be able to do a perfect square trinomial or a difference of squares or something like that. And then solve for x, which means just put it equal to 0. So our first problem says solve the quadratic by factoring. So the very first step is this in standard form? My a is 1, my b is -6, my c is 8, and then it's set equal to 0. So that's in standard form. So that's done. Is it set equal to 0? That's done. Can I GCF it? What do 1, 6, and 8 have in common? Well, the only thing that 1 can possibly be is 1. Do they have x's in common? Nope, so there's no GCF. So now I'm at the x method. So here's my x. Remember, it's AC on the top, B on the bottom. They multiply here and add to these factors. And I'm just going to show you here. Since my A value is 1x, I'm just going to put my x's here. So now what multiplies to 8? Because it's 1 times 8. So what multiplies to 8 and adds to -6? So the only way this happens, if when this is positive, they both take B sign. So this is going to be -2, and this is going to be -4, because what's -2 plus -4 is -6. All right, so now we do bottoms up, and we get x minus 2 times x minus 4. And this is set equal to 0 because that's what this is. We're just breaking this down from trinomial form to two binomials. And now we drop parentheses and solve. So we get x equals 2. And then we get x minus 4 equals 0. And we get x equals 4. If you notice, I really didn't show you the algebra. I'm going to show you the shortcut. If you have just the x as your lead term here, it's just the opposite. What's the opposite of negative 4? Positive 4. What's the opposite of negative 2? Positive 2. So these are my two roots, my two solutions, my two x-intercepts, my zeros, all that stuff. Do you see why they're called zeros? Because we're setting them equal to zeros. Oh, I left that blank for my work. Now here, let's see. Is it in standard form? X squared, x constant, good. Check that off. Is it set equal to 0? Yep, so I checked that off. Can I GCF this problem? 2, 12, and negative 14. Looks like they have what in common? A 2. So that's going to simplify this to x squared plus 6x minus 7. And that still equals 0. What did I do? I divided each term by the GCF, which was positive 2. 2 divided by 2 is 1. X squared, blah, blah, blah. So now what do I do? I'm going to try to simplify this down to factored forms. So how do I do that? I'm already down here. I did standard form, swap, GCF. Now I want an X method. So what multiplies to negative 7 and adds to 6? We get 7 and negative 1. And again, I could do the bottoms up thing with just my AX on the bottom. My A is 1. So that's going to get me X plus 7. And it's going to get me X minus 1. Because again, when I multiply these two, I get negative 7. When I add them, I get positive 6. So now what do I do? This is why I had this over here. I get x plus 7, x minus 1 set equal to 0. So I do x plus 7 equals 0, and x minus 1 equals 0. Again, if you remember, the shortcut is if this is just x, your first term in that binomial is just x, we're just going to take the opposite. I can show you the algebra as well. However, I can just do the opposite. Opposite of positive 7 is negative 7. And then again, x equals 1, because that's the opposite there. So these all so far have two solutions. Remember, we could have no solutions, doesn't touch the x-axis. One solution, the vertex, that special point, is on the x-axis. And then we have two solutions where the two arms go through the x-axis. Here, is this in standard form? Check. Swap out y for 0. I already did that. Can I GCF it? 3, 4, and 1. Do they have anything in common? Nope. So I'm going to I did that. X method. I have my A times C, my A value, and my X on the sides. What's A? A is 3. What's C? 1. So I'm going to get 3 here. What's my B value? Negative 1. So again, because my C value is positive, they're both going to be negative. The only way to get that is negative 3 and negative 1. Because what's negative 3 times negative 1? Positive 3. What's negative 3 plus negative 1? Negative 4. So now we simplify this wedge over here, and we get negative 1 over x, because I took a factor of 3 out. This does not simplify. That's in simplest form. So now I get bottoms up. I get x minus 1. And I get 3x minus 1 over here. And again, this is set equal to 0. So I'm going to give myself a little bit more room and rewrite that over here. X minus 1. And then this was 3x minus 1. And set these equal to 0. So I get x minus 1 equals 0. And again, if you know the trick, it's real quick. Here, I really can't do the trick. I'm going to have to do some algebra here. Add 1 to both sides. And I get 3x equals 1 divide by 3, I get x equals 1/3. So it's a fraction, but it's still crossing in that first quadrant. I guess it's on the axis, so it's a positive x value though. All right, so here's a word problem. The equation of the height above the water for another diver can be found or can be modeled by the height equals negative 16t squared plus 8t plus 24. Find the time it takes the diver to reach the water. So is this in standard form? T squared, t, 24, that's done. Swap out the 0. The height is my y-axis, so I'm just going to use that as a 0, right? And again, when we plug this into Desmos, if we had to, these are x's instead of t's, just because Desmos likes x's and y's, not t's and h's. So this is going to be x squared plus 8x plus 24. That's good there. Now, if I GCF it, what can I take out? I think 8 goes into all these, so I'm going to get 0 equals 8. So if I take a factor of 8 out of all of these, I divide by 8. That's a 24. And I get 2x squared, negative 2x squared, right? Sorry, I want to take out a negative 8 to make this positive, silly goose. So I get positive 2x squared. I get negative x, and I get negative 3 now. So now that I have that, I break this down with the x method, and I get AC on top, B on the bottom. I get my side wedges of 2x, because remember, it's just the a and an x term. 2 times negative 3 gets you negative 6. And they add to get negative 1. So what multiplies negative 6 and adds negative 1? Negative 3 and 2. So now I'm going to simplify these two things over here. Can this wedge simplify? Nope. So I go bottoms up, and I get 2x minus 3 for this wedge. This simplifies, 2 comes out, so I get 1 over x. And I go bottoms up, and I get x plus 1. So now I have this binomial, and I'm going to solve for x. Let's do that on the next page. 2x minus 3 times, what was it, x plus 1. So 2x minus 3 equals 0, and I go x plus 1 equals 0. I'm going to do the easier one first. That one's done. So there's one root, and my other root, do the inverse operation over here to get x by itself, and it's a nice number of x equals 1.5. So here's the thing. In context, we're talking about these things. And this is a factor. So I set negative 8 equal to 0. Does that make sense? No. So that doesn't work. I said x equals 1.5. And I said x equals negative 1. If we're talking how long it takes a diver, does negative 1 second make sense? No, because you can't go back in time. So your final answer, so this wouldn't make sense. This doesn't make sense, even though that's a factor. And this is your logical answer because it's going to be 1.5 seconds. And that's going to be a positive time. And remember, time can only be positive because it starts at 0 and it never goes backwards. All right, that's why this negative 1, although it's an answer, it's kind of a dummy variable or dummy answer because you can't have that in context with a word problem with time. All right, last but not least, number 1 says, is it in standard form? Nope. So how do I put it in standard form? Real simple. What am I moving? I want to put 5 to the other side. What's the opposite of positive 5? Negative 5. So now I get this. And what's going to be on the right side is 0 because this is the 0 product property. And now is it in standard form? Yep. Did I swap out my zeros? Yep. Do I have a GCF? 1, 4, and 5? Nope. So that's done. X method. What multiplies to negative 5 and adds to 4?
I don't know that one.
Alexa said, I don't know that one. Interesting. She's
on for what time?
She's always listening. Do you hear that? It's kind of creepy. So anyways, 5 minus 1 gets you 4. 5 times negative 1 gets you negative 5. So I'm going to do that bottoms up because my 1 is my a value. And I get x plus 5 and x minus 1 equal to 0. And now I just do the opposite. X equals negative 5 and x equals positive 1. Okay? Any questions? Again, you know what to do. Pause, rewind, send an email, raise your hand. We'll help you out. All right? Last but not least, we talked about graphing. Graphing with Desmos. There's one thing you have to do, and I know you all are capable of doing it, and it's just make this what? You can't have this equal sign, so we're going to combine like terms. All right? So when I do that, I'm just going to keep this x value positive, and or x squared value positive. I'm going to subtract x squared over here. And I'm going to move 3 to the other side as well. So when I do that, this goes away because x squared minus x squared gets you 0. What's 3x squared minus x squared? Get you 2x squared. I'm just moving everything from the left to the right is what this means, right? Anything that shows up on the left, I'm going to put on the right in the opposite because left and right are opposites. So here's what I just did. And I'm going to move this negative 3 by subtracting it. There's nothing for it to combine with over here. So that's going to go at the end. And I get my negative x over here in the middle, just to be in standard form still. And if I look, what is on the left side? If I moved everything, what's over there? Nothing. It's 0. So I'm just moving this and combining with that, moving this over here, and it doesn't combine with anything. So now I can put this in the Desmos and graph it. So when I do that, I get 2x squared. I don't know why it does this, but nope. 2x squared minus x. Let's see if I have my tablet home. 2x squared minus x gets me minus 3 as well. So how many solutions are there? Zoom in on this bad boy. And you got 1, 0, and 1, 0. 1 plus 1 is 2 zeros. We get 2 zeros here. Negative 1 and 1.5. Here, I'm going to do less work and move 25 to the other side. What's the opposite of positive 25? Negative 25. So it's going to be x squared minus 10x minus 25. And that equals 0. So let's plug that into Desmos. And I get x squared minus 10x minus 25. This is a negative. Just kidding. There we go. That looks better. How many answers do I have here? I only have 1, right? You can see only 1 silver ball comes up, and it's that point. So you can see that this has 1 solution. So this was 2 solutions. This was 1 solution. And I know what you're guessing. Ready? Let's go to this one over here. I'm just going to move both of these and go x squared minus 5x plus 10. And I can't see it because guess what? It doesn't touch the x-axis. Again, all I did was I changed it and I moved everything from the right over to the left. X squared does not change. 5x turns into negative 5x, and negative 10 turned into positive 10 because I moved these two terms to the left side. They don't combine with anything over there. All right? So I can graph it, and I see that there are no solutions. So that was purposely done. I have my 2 solution, my 1 solution, and my no solution set. Okay? One last question. Just kidding. It's the last slide, the best slide. You know what to do. If you like it, subscribe, thumbs up. Other than that, I hope you understand the lesson. And here we go, brownies. Here we go.